Namaskar, my dear friends. Let us talk about FPGA circuit design now. So we have already discussed a lot of things about FPGAs, like how we can select FPGAs and what are the different things. We will be taking one of the device that is there from Spartan 7, and the part number for this device is going to be XC7S50-1FTGB196I. Okay. And as you can see, there are various applications of FPGA and like how they can be utilized. So we will see a brief discussion on this particular FPGA, their parameters and like features and all those things. And then we will proceed with the circuits that we are going to talk about. Okay. So this is a very simple circuit that we have developed using this particular FPGA, a power supply or symbols and all those things. And then we'll proceed a complete design process of this circuit. All right. So before proceeding to this particular XC7S50 device, which is going to be 196 pin IC. Okay. So what we have done is here, I have taken all the four variants of the same, FTGB 196, right? So you can see we have C version and we have I version, okay? And the speed grade is grade 1 and grade 2. So grade 1 is lower speed, grade 2 is higher speed. And we have C is nothing but your commercial temperature range and I is nothing but your industrial temperature range. So which temperature range that you want to take in, you can go ahead with that. We don't have availability with expanded temperature range for this particular IC series, so we have only two versions. Okay, so we'll talk about all these things, like how we can go ahead with power supply designs and power sequencing and all those things. Before that, we'll just quickly take into the resources of FTGB 196 package pin, which is going to be XC7S 50, and this is, you remember, this is AMD FPGA and this is going to be a Spartan 7 series. So as you can see, we have logic resources, like logic cells are 52,160. Then we have slices, we have CLB flip-flops, we have maximum distributed RAM, we have memory resources, like we have block RAM, we have total RAM is 2700 kilobits. Then we have clock resources, we have IOs, so total 100 IOs are there in that. I have not counted here, so I have not written this. Then we have embedded hard IP resources, like DSP slices are 120 and all those things. It has even ADCs, and speed grades and temperature grade both are available. Okay. If you talk about the details of this particular IC, so you can see we have recommended operating conditions and all these things. Okay, so this is a very important part that we always take into account before designing the circuit. Okay, so the core supply voltage is going to be 1 volt. So we need 1 volt voltage source. Then auxiliary supply is 1.8 volt. Block RAM is 1 volt. Then supply voltage for VCC IO, that is your logic input, will be going to 1.2 volt to 3.3 volt. So generally all the logic labels we have used right now 3.3 volts. So we are not changing that. Then we have IO input voltage that is going to be 0 to VCCO. Okay, for analog inputs. Then IO current output, it can give you up to 10 milliamperes of current. Okay. So if you're driving something, some load from one of the IOs of this particular IC, you have to make sure that you are not drawing more than 10 milliamperes of current. Okay. Then we have battery voltage that can be taken from like 1.2 volt to 1.8 volt. Some other parts you can see we have ADCs. So ADCs is going to be having supply voltage of 1.8 volt. The reference voltage is going to be 1.2 volt. Operating temperature, as I told you, there are three grades that is available: C, I, and Q. So C is 0 to 85 degrees centigrade. I is minus 40 to 100 degrees centigrade, and Q is expanded temperature range of the IC, which will be minus 40 to 125 degree centigrade. Okay. If you talk about this particular IC detail more about it, so manufacturer is AMD. It is nothing but Xilinx, but Xilinx has been acquired by AMD. So now AMD is the manufacturer. Manufacturer part number is this. Instead of C, you can take it I. C is also there, but lower temperature range. And I is higher temperature range. This is Spartan 7 series. Mounting type is, of course, it is SMD package. It is having package of FTGB 196, and this is the size 15 mm cross 15 mm, and the ball pitch is 1 mm. So you can see this is the like IC that it will look like. Coming back to the compatibility, so package compatibility, if you want, you can like have I mean temperature variation was fine, like C variation or I variation. However, if you want to have like downgrade your device like that is XC7S50, then you can go ahead with XC7S25 or XC7S15 or XC7X6 also. Okay, so this is a beauty. So you can see from here, like XC7S50, we are going to XC7X6 also, and you can see all of the FTGB 196 is available. Okay, so FTGB 196 with 100 IOs each one of them. So that's the beauty of this particular device. And this particular device, why we have started with, as well as we have used in several low cost design or low end design, because this is very easy to design, and this is going to be very nice. All right. So what are the things that we will follow, like during the design of this particular FPGA devices, we'll follow a process. Okay. So first of all, we'll follow FPGA symbol. So we'll make the symbol, we'll create it, and we'll assign pin numbers and their pin names and everything. Then we'll follow power supply management, power supply. Okay. Then we'll go ahead with configuration and programming. Configuration and programming method, like we'll generally take it uh, like platform cable USB to platform cable USB to. Then we'll go ahead with IO connection. So we'll try to connect, like how to connect LEDs or like switches, and then we have like push button or switches is fine. Then we have deep switches. We'll also connect several other parameters like how to connect ADCs or EEPROM and DAC. So these are the like different things. We will have also like flash memories and everything, like flash memory, using some SPI, quad SPI and everything. And then we will try to like add different parts of circuits. Let us say like several ADC, DAC and all we already saw. Like let us say how we can utilize multiplexers, and something like this. Okay. All right. So with this, let us get into the circuits that we are going to see. So as you can see from the circuit point of view, so very first thing that we have to do is we have to nicely make this particular symbol. So as you can see, we have the Spartan 7 symbol in heterogeneous package. Like I have 1, 2, 3, 4, 5. So total 5 parts are there in 196 pins. So as you can see, I'll just zoom in one by one. So all the configuration pins are listed here. Okay. Then similar to that, all the bank 14 are listed in this particular like section. Similar to that, all the bank 34 are listed in this section. So this is very easy and very understandable that if we are going to like connect some or like interface some IO signal or maybe the memory devices and all those things, peripherals, we will be able to assign at one particular block. And their corresponding particular block, like power supply is also connected to that only, right? So this is the way, a very good method of this. Okay. Then this is the power supply that you can see. We have a core power supply, we have auxiliary power supply, we have block RAM power supply. So all the power supply pins are, like clubbed in single section. Similar to that, all the ground pins are there in this particular sections. You can see we have total 50 ground pins, like ground 1 to ground 50. So all are GND pin. However, to have the proper compatibility, they have been like numbered as 1 2 3 4 5. You will not find the number in the like pin diagram or pin description in the data sheet. However, we have numbered it for our convenience. Similar to that, here also the numbering is done for our convenience. Okay, so hope you have a very good understanding up to this particular symbol preparation. So what I will do is I will open like ORCAD, and I will show it to you how to do that as well. So you can see you can see we have this particular like understanding. So let me make it little bigger. All right. So this is how you are having all the pins. Okay. And similar to that, we will be connecting some lines, and we'll try to like connect it to some other place. So what we'll do is we'll start with the next session, and we'll try to explain you each and every like circuits, like how we have converted or how we have made the configuration and what are the different things each and every place. So thank you guys. If you do have any questions regarding like proceeding for FPGA circuit design, you please put down your questions in the comment box, and we shall be able to answer you out. Thank you.